morning, everybody. This is Josh Ellsworth with Stahls TV, and we welcome you to today's Stahls TV live presentation, Creating Stunning Fine Detail with Laser Cutting. I'm joined by Dave Stevens, who's the Senior Technology Specialist over at Universal Laser Systems. And here at Stahls, we've been working with Universal Laser, collaborating over the past 12 to 18 months on this new exciting application for laser systems and for heat transfer films and heat presses. So we got a nice little crowd today, and as always, if you have questions throughout today's presentation, it's real informal. Just type them into the question box, and I'll stop it several times throughout today's presentation to either direct those to Dave or answer them as well. And so, Dave, first, thanks for joining us this morning.
My pleasure. Thank you. Glad to be here.
Okay, and today most of the session is tied up into a PowerPoint presentation, and we're also going to do a little software demo, a little video sharing, so you can understand really how to use your laser or perhaps invest in a laser for cutting heat transfer films and the benefit of that. So to start things off, I do want to launch a poll to understand, as people are still sort of filtering in, and understand how many people in our audience actually own a laser cutter already. So if you can take a moment to answer that. Let's close that off, and I'll share the results with everybody. So you can see that the majority of our audience does own a laser cutter, and 33% do not. So good. So hopefully for those of you that own the system, we'll give you some ideas on how to process these materials accurately and what you're really capable of doing with heat transfer films. And for those of you that don't, hopefully we can give you some ideas of what you need to look for in a laser and some of the possibilities and reasons you may want to invest in one. But just to sort of catch everybody up on the basics, I always like to start with a heat transfer film or heat transfer vinyl overview. Now, I put the word vinyl in here because it's commonly referred to as heat transfer vinyl. But for anybody that's been around the industry over the last 5 years, you know that vinyl is really only contained polyvinyl chloride in some of the heat transfer films that are on the market. Although it's used as a generic term, something very important to our conversation today is whether or not the material is comprised of polyurethane or versus vinyl. And so I'll go over that in the next slide, but heat transfer films in general are manufactured in a variety of effects. Here at Stahls, we've been manufacturing heat transfer films for 20 plus years. Actually invented the category with a product called thermofilm, which at the time was polyvinyl chloride, and eventually was redeveloped about quite a few years back to be polyurethane based. But heat transfer films come in a wide variety of styles. So if you have a laser and a heat press, basically you are able to start utilizing heat transfer films in the business. And I'm going to sort of swap over to the Stahls website here. Knowing that these materials come in a wide variety of styles and finishes, all you need to do is click on CAD Cut Heat Transfer Materials, and you can quickly see a preview and a quick explanation of all the materials that are available on the market. So with your laser in a heat press, or even with a knife cutter in a heat press, if you have one of those, you can begin to decorate team uniforms. You can do lightweight graphics on apparel. You can do performance wear and stretch fabrics. Of course, you can apply to bags, and you can also start to get into special effects like glitter materials or glow-in-the-dark materials that are going to present new and additional opportunities really for you to sell more to customers you're selling laser engraved products to. And so we believe that this is a perfect fit for you, and not only can you do basic graphics, but you can do a whole lot more, and that's what today's presentation is focused on. And before we go too deep, just to understand, polyurethane is absolutely critical, as I mentioned. When you look sort of at the breakdown of a heat transfer film, I'll grab my pen here, you can see that there is a carrier layer of the film. That's usually a sticky backing that holds the heat transfer film onto the roll. And then you have the actual film layer of the product that's laminated to that carrier. Now, this film product is the product that should be a polyurethane composition to ensure that it is laser safe. And then basically, as you'll see, we've done a lot of the work for you. Actually, Universal has done a lot of the work for you to make it easy to process these different thicknesses of polyurethane films, specifically in the Stahls lineup. Particular one that we have an up-close view of here is fashion film. It's 88 microns thick for the actual film layer, and so a lot of the settings are preset in the laser profile to make it extremely easy to process. And so as long as you have a polyurethane-based film, the Stahls materials, we have a lineup that's been approved as laser safe and went through the testing to say it doesn't have any PVCs, lead, phthalates. Not only is it safe for laser processing, but something else that's big in the apparel world, the reason you'd want a polyurethane film is so you can apply it safely to children's apparel and meet CPSIA compliancy, which is the Consumer Product Safety Improvement Act, and basically saying if this comes in contact with the mouth of a child, it's going to be safe to wear, safe to decorate for the larger market that's decorated apparel. And so once you have a firm understanding of the types of films that are available, and we have a whole list of compatible materials over at stahls.com that's compatible with the process, then we start to dive into how does this work? How do I process the materials? With heat transfer film in general, you're basically cutting through that film layer that we looked at, but in most cases you're not cutting through the carrier. We call this kiss cutting, basically through the film, through one layer but not through another. And what that does, it's basically what makes the process work, in that I can cut something, I can weed away, which is the process of removing the excess material away from the carrier, and basically have a pre-spaced graphic that's ready to just flip over onto the shirt and heat apply. Everything stays in perfect registration, and for screen printers, really, this solves a huge issue in that it gives them a way to do small quantity runs without the cost of burning a screen. So if you want to do a 6-piece order, it can be very cost effective with CAD cut heat transfer films. And as you'll see, we start to pull away some of the limitations or some of the time-consuming parts of the process when we talk about laser processing versus knife cutting. Okay, so I tend to talk a little fast, so I'll stop and breathe several times. And when we look at the image that's on the screen, basically we have two different things. This particular graphic has been laser processed. If you look, basically this outside edge where you can still see the film up against the carrier has been kiss cut. Basically the laser's been programmed to cut through the film but not through the carrier. And then the areas where you see the dark black sort of at the center of the letters, which is most noticeable, probably right here at the center of the S or the E in this bullets word mark, you can see that's cut completely through. If you're familiar with heat transfer film, you know that the most time-consuming part of the process is something called weeding. Now, we've come out with a variety of innovations to improve weeding, but when you can completely eliminate the weeding of interior components where you don't have to pick those and pull them out through laser cutting, specifically die cutting and programming the lasers to cut through these cavities, you can reduce a lot of the labor in the workflow. And so I have sort of some images that will give you a quick explanation of how art can be set up. Dave, do you mind talking specifically to this image and what we're looking at with the different color lines?
Yeah, no problem. The laser utilizes different colors for different operations. And when we use these different operations, the presets or the automatic modes automatically utilize these colors for different power settings. And so in this case, I've taken the Stahls logo and converting it to just an outline. And in order for the laser to identify to cut through versus kiss cut or just kiss up against the backing of the material, we use different colors. In this case, the blue is identified to cut through just that top layer, leaving the bottom layer alone, similar to your knife blade cutters. But then, in addition to that, just by modifying the file, by converting the inside components to a red, the laser automatically sees red as a cut through, and our driver automatically sees that as also a cut through. So by designing your file like this, breaking your text apart, and then in essence taking all the inside components and changing the color, the laser will cut all the way through these areas, while in turn kiss cutting or just cutting up against that top one or your top layer, just like your knife blade cutter. So that in this case, I would peel once and no longer have to remove all those little pesky inside components.
Great.
And that's all there is to it.
Yeah, and so here's a quick view of what that would look like processed. And the beautiful thing is here, as you can see, this is a glitter material, and you, in the normal process, look at all the little center marks under the small text. You'd have to weed all of that out. And with glitter, sometimes doing that fine of detail with knife cutting just isn't possible. So not only are you getting the benefit of accuracy in cutting clean corners and making sure everything is just completed with the laser, but we're also able to remove some of the weeding from the process in how it completely blows through the cavities of the letters based on your art setup. And so when you go to weed this, you know, here's what the finished product basically looks like with the film removed. And so any of you out there that have cut glitter heat transfer films before, any heat transfer film for that matter, and completed the weeding process, just for perspective, this design is a small left chest logo, and we're talking very fine text. We're able to hold that sort of detail really easily and peel away the outside edge in one solid piece. When we start to look at this, I believe, yeah, here's a finished result. This is on a miniature t-shirt. If you guys have ever seen the mini t-shirts, it's a great way to market the business, your business, and give samples out. They're available on Stahls.com, but you know, we just applied that to give you the visual. So you can see just the film applies. The carrier doesn't damage it at all, and basically by cutting through the center cavities, we drastically reduce the labor. Dave, I'm going to try to throw control over to you to see if you can just talk through a little bit where the material profiles are located in the basic art setup. Let me see if I can give it to you here. Should be coming your way. Excellent, we got you.
All right. Yeah, from any design software of your choice, in this case I have CorelDRAW X8 open, you can print to the laser system from any of these design softwares. And so in this case you have the ability to design your file, and here's an example of an engraving file which we'll get into later. But all I have to do is hit print from my design software, select the printer, and go into my driver. Just like any desktop printer, once we select the driver, it shows a list. In this case, our driver shows a list of materials. From a materials database, all of our settings are preset, so you don't have to figure out the settings. You don't have to determine what the powers and the speeds and the settings are. So in Stahls' case, we've spent a lot of time developing a setting specifically under the fabric category for the Stahls materials. And unfortunately, I realized I have the wrong driver on here. I'm sorry, Josh.
That's okay.
Yeah, I don't realize that. But within here, we have the ability to actually select the materials database and all the different Stahls materials so that once you select those materials, the presets are done. Your power settings, your speeds, your feeds, your engraving settings for all the individual components of their products. Right now we have 10 or 9 different Stahls materials within our database, so that an operator would just design their file, push print, select the material, and then push start. Presets and material thicknesses are also located into it, and then the 3 different colors, the black and white for engraving, the blue for kiss cutting, and the red outline would be used for cutting through the material. And once we would hit OK, you would just push print into our driver, and then our driver would pop up, and then you would have full operation to that system or that file. And then you would just place the material into the system and push start. In this case, this would be just a cut file, for example.
Excellent. And so one of the key things that I love about this process is that you're pretty much wide open, whether you design in CorelDRAW, Adobe Illustrator, even for those of you that are using CADWorks Live, as long as you can basically print to that file or even export as a PDF and import into the driver, basically all of the presets are handled in the driver. And so as long as you sort of colorize with those RGB values that the laser recognizes, it's going to process and take that labor out of the equation for you. Correct, Dave?
Yes, absolutely.
Good. And so that, that gives you a basic idea of the simple laser cutting. And then I just want to show you, I have a quick video that's queued up that I'm going to play here for everybody. There we go. And so this is one of the universal laser systems that we've purchased in the early stages to use up in our product development lab, and just shot some videos. But Dave, you're seeing this moving, correct?
Correct.
Okay. I just wanted to make sure. Sometimes the video is a little bit different within the PowerPoint, but basically here we're doing a complicated font, and you can see we kiss cut the outside. Now the laser is coming back and die cutting out the centers. And if anybody's ever weeded this font, it's the Curls font. You probably didn't do it more than once. You also notice when we die cut the outside edge, we've programmed an alignment notch. So it's actually going to help us in application. One of the biggest challenges of the process is lining stuff up to make it easy to heat apply and accurate. And so if you add a laser alignment device to your heat press, you can shoot a crosshair laser on there and use the alignment tool to make sure it's straight on your shirt. So you can see in this image how all the centers are punched out. Very easy just to weed the outside edge. And so that basic laser cutting, kiss cut, die cutting, to me it's enough to justify the investment by itself. But the title of this webinar was Stunning Fine Detail. And that's really where this workflow allows you, a laser allows you to create graphics that you would otherwise be unable to create through any other process, really. Very much so not through traditional knife cutting. And so the way we've sort of tagged this workflow, we talk about it when we say laser marking or photo processing. We call the process raster ablation, basically the idea of ablating or removing small details and cavities or portions of a photographic image in a way that, once again, eliminates the weeding, eliminates the most time-consuming step of the process, and really allows detail. You see this fine text out of fashion film up against the size of a finger here, and you know this is very small text, like for the inside of a tagless shirt. So really a lot of capability there. And I'm just going to, we have some questions coming in, so I just want to stop briefly to make sure everybody's up to speed. So Emma asks, can you show me quickly where you import the material settings? So basically that's in the universal driver itself, Dave, correct? How do they go through to make sure that they have the Stahls database in the driver?
Yeah, well, I mean, the Stahls database is just a matter of hitting your update button in our control panel. Once you have updated to the latest version, you will have that database located in the materials lineup. I apologize, I had reverted back recently for a customer, so mine didn't show up right in the moment, and I forgot to check for that. But in that list, it will show up. And now, if you want to direct import a PDF or a DXF, it is an additional mode that needs to be turned on and initialized in our driver, but it virtually eliminates the need for design software in general on the computer that's running the laser. From the control panel, you just go into the actual files, and then you do what's called an import. And we can currently import a direct PDF format and a DXF format into our driver without any need for graphic design software on the computer that's running the laser.
Good. And then for those of you that are joining perhaps late, Dave Stevens is the gentleman talking, the Senior Technology Specialist for Universal Laser. So he's definitely referencing the Universal Laser driver. So if everybody can take a moment, if you do own a laser, just go ahead and type your brand into the question box for me so I have some good perspective on how many of you own Universals right now versus perhaps another brand laser. So perhaps later in the presentation we can speak to that. Okay. So let's talk about laser marking and photo processing. And Dave, I know we've been to quite a few trade shows together, and this is really what draws the crowds into the booth.
Yeah.
Good.
Yeah, Absolutely. This is the ability to go beyond the detail, and instead of doing small detailed prints and logos and small text, I've developed a filter in our one-touch laser photo software that gives us the ability to take the thin films, only the really thin ones such as the fashion films, and convert an image, any digital image from your phone, download, or scanned image into a digital file that can then be transferred onto this film, utilizing our software to then imprint full photographs of your choice onto any apparel object.
Yeah, and I have just some quick images that sort of outline the workflow. This is going to go through the laser marking, and then the photo imaging will directly follow this. But basically,
well, this one would not be a photo. This is just black and white. No photographic mode was used in this case.
So let me go to I want to go to the photo one here, which I have right here. So this is the process. Basically, we bring in the photo through the one-touch laser photo system. You convert it correctly. And then basically you can see the Stahls material database listed here to the right. And so you select the material you want to process it on. As Dave mentioned, the thinner films tend to work better. That's why on the Stahls product pages you'll see the micron thickness of the films. If you can pick a film that's, say, 100 microns or less, it's going to work a lot better than, say, trying to process a photo on a thick material like thermofilm or glitter. But basically, after you do this conversion, the laser processes the photo, and literally you just flip it over and heat apply. And the only thing that sticks is the film, and then you get a photorealistic image onto the garment. So I'm going to play a quick video clip here. And I know there's some questions coming in, but this will show you sort of the process and the speed. Now, Dave, I know you've worked with this a lot at the different trade shows. Any best practices when you're doing this sort of ablating or photo processing, etching away, to take into consideration?
Well, the only way this is going to work is you need one-touch laser photo software, which in turn actually does the conversion for you. And this software will work on any brand of laser system. It's a standalone software, so that it basically converts it to a black and white pattern best suited for the material. And as you can see here, the image is, in essence, everything around it is vaporized. Because the laser has such high detail, we can ablate everything except for that photo so that it can actually be heat applied. Color combination is a concern, so you don't want to use a light color on a light color. Our photo software has two different modes, a dark mode and a light mode, depending on what combination you're going to imprint on. So if it, in this case, is a white film on a black t-shirt, in this case the image would not be inverted. But our photo software will invert it for you depending on the combination that you can put it on. And I can demonstrate it on one-touch photo if you'd like, Josh. I have it up here.
Yep, absolutely. Let me throw it over to you here, because I think that'd be beneficial, because I see a few different brands of lasers coming through. And so the fact that this is a standalone solution that could benefit anybody that currently owns a laser or is looking to invest is definitely a great thing to go over.
So as you see here, this is a one-touch photo software. You can download it right off of our website, and there's a free 30-day trial for those of you who would like to test it. Once you open the software, we will open up a graphic. You can size it and scale it within our software as well. And I do recommend that image has to be sized and scaled. You do not want to scale it or size it after it has gone through this process. So you want to do it in your third-party software or within this software. So in this case, if I wanted to etch this onto a shirt at 3 inches by 3 inches, I can crop this and size it at the same time. Then step 2, as you can see here, we have lots of different materials for doing photographs on it. But within this material database for the photographs, we have Stahls CAD Cut Dark, and this is if you're going to be etching a darker material. And then we have Stahls CAD Cut Light materials. And we didn't put all the different colors because Stahls offers so much variety. Ultimately, if you're doing a lighter surface material that's going to go on a darker a piece of apparel, you want to use the light material. And if it's a darker material going on a light, or if it's darker going on light, or if it's a lighter material going on dark, then you would select the correct one, and then you would hit apply. As you can see here, this renders it to a very specific screen pattern to which we have done a lot of work in developing edge enhancements, gamma correction, midtone corrections on the photos, taking that photo and converting it to a black and white dot pattern. And this dot pattern is specifically designed to work with the Stahls CAD cut materials. And then I would either save this and bring it back into my design software at this size, not scaling it, or if you use a universal laser and you just want to imprint or engrave this photograph, you can print it directly to the driver, and it's going to link into our materials database from here. Both will work. If you're going to add text, or if you want to use a cut path, then I would suggest saving it and then taking it into your design software so that you can add these additional components from this point. But that's all there is to it. Pick the light or the dark material after it's sized and scaled, and then render it, and then save it or print it from here.
Good, good. While we're there, Dave, do you mind walking through just in general the laser marking process where somebody may want to utilize ablation for fine detail like we saw in that sort of tagless text-based application?
Yeah, I mean, ultimately it comes down to your design software. And when you design something in your design software, if you want to do that ablation, here's a good example of the cutting through material. But if all we would do is just design something in kind of a rubber stamp or an inverted state. And so I would design text on whatever size of that text may be, turn that text white, and then I would mirror the whole graphic. This is the entire process that would be necessary in order to do that ablating process. So in this case, the laser, and then once you have it designed here, you can basically convert to any image you want, and you can retest and type it. It does need to be a mirrored graphic, but this is what the laser needs to see for ablating. So the white would not be engraved, and the black would be engraved away. And so whatever size or type or image quality you have, and this can be any type of graphic, and once you have the files set up, as you can see here, I have created graphics, logos, highly detailed imagery, and this is just black and white graphic. In addition to here is a photograph that I rendered in the one-touch laser photo. Then I saved it, brought it into my design software. I also do a nice tight cut path around it. This is going to just reduce any chance of any excess bleeding or residue going onto the material, giving you a far more accurate cut. You can also, as Josh showed earlier, we can place notches into the carrier film so that if you want to do more than one color, you can process more than one color and then use these notches to actually interlace different colors together, kind of like a puzzle piece, prior to heat applying your material. And then from here, we would then hit print and just select the correct material, and I can do graphics that are just black and white next to colored full photographs, or all of the above, all at the same time on your laser system, up to the field size of your system.
Yeah, so when you start to really think of the capability with what you're able to do, I mean, we're talking a couple things. Number one, it's small graphics and fine detail, photo processing, but really if you take those two processes and really put this into a designer's hands, the results that you can get are just phenomenal. When you start to think of small details, whether it can be a distressed effect that could be through a graphic on the front of a shirt. It can be photorealism within a particular team logo that's part of a larger graphic. So when you start to take in to account the capability of this, ablating away the excess to achieve the fine detail like you see on the screen, or to use the one-touch photo software to process the photography elements in a heat transfer film, it really just opens up the capability for low quantity customization, stuff that typically you'd only be able to screen print or perhaps only get onto light colored polyesters through sublimation or have to go through a long workflow to DTG a single shirt. Now, with the power of a laser, you can start to create graphics that are really unmatched anywhere out there in the market and differentiate your business. And so I think that's one of the big takeaways here is that if you have a laser already, you can leverage the capability to grow your business. Or if you do a lot of heat transfer film work and you have a heat press, really you can step up your game by investing in a laser and starting to use a laser for the process. So with that in mind, there's one sort of other component as I'll look at the questions here before switching gears that I want to talk about leveraging the laser for applique, because I know we always have a good number of embroiderers that join us here on Stahls TV. Okay, so there's a request if there's a way to go through the entire process with both photos and clip arts from start to finish. So that's something that we'll do. There's a user guide that we'll share out on the Stahls TV blog after this presentation, and you guys will be able to download the user guide, and it will literally walk through the start to finish process with the workflow to make it a little easier to follow if you want to try it on your own. The only other question is settings for other lasers. So Dave, any recommendations if somebody owns another brand laser, how they would begin the process of trying to utilize this?
Yeah, I mean, it's going to come down to trial and error. That's basically what we do to develop our materials database. You need to kind of match your speed and then start varying your power setting until you get a clean removal of the material. My recommendation is to start low and then start engraving the material. And if you still have leftover material, you need to keep bumping up your power until you get a nice clean removal. The problem with this material is you can't hit it more than one pass like you can on, say, woods and plastics. Otherwise, because the excess heat tends to melt the carrier film. So you want to kind of find that sweet spot in power while maintaining a consistent speed so that you get a nice clean removal. And then when the image is then imprinted, you get no excess residue left over. The key is to try a darker material, CAD cut material on a lighter shirt. If you get a nice clean transfer, then you've kind of found your settings, document those settings, and then you can continue to use it for that material. In addition, there are going to be different settings based on the different CAD cut materials you choose, and that's why we've developed them for each material setting. So you kind of have to develop them each in addition to that. Some materials work better just for the kiss cutting, which is an easier setting to determine, but the engraving setting does take a little bit of trial and error. And some have been successful, others have been more difficult. And that will depend on what your total wattage is. Higher wattages, really high wattages, may be difficult to control because this is kind of in your middle tone. For engraving, 50 watts is about where I recommend. You should be able to run your system at about maximum speed. You can do it with any wattage, but most systems allow about full speed, about 50 watts. Less than that, you can't run your system at full speed. You can still do the application. More power, you just have to throttle it way back, and it's harder to control.
Good. And then there was another key thing, right, with as far as the honeycomb table to process. Is that another recommendation?
Yes. In order to run this material, it has to maintain a very flat base. It has to stay consistently flat. And the honeycomb tables, at least with the universal product, actually creates a vacuum. And so you want to utilize some sort of vacuum table in order to hold this material down. You can tape it on the edge and stuff like that, but the excess heat from the laser can actually cause ripples to start forming due to the heat of the laser. And the vacuum table will hold it down, maintaining a very consistent hold-down mode while the laser etches, ablates, and cuts it away. And without this accessory, I wouldn't truly recommend this application.
Good. Yeah, so key is holding the material flat, and I know that through trial and error, we found that, cutting your weed border, we call it a weed border first, or like the bounding edge of your graphic sometimes helps to reduce a little bit of that puckering and shrink that you get when you're particularly etching the material. So whatever you can do to make sure you hold the material flat, It's going to prevent warping in the graphics and give you really the output that you're looking for. And if you do have other lasers, one thing Stahls does is we always offer sample sheets of our heat transfer films, but if you're really going to dial it in, you may want to purchase some 1-yard cuts, and I'd recommend starting with fashion film. That's sort of the basic go-to material for us, one of our fastest growing products. Feels great on t-shirts and does really nice in the lasering process with holding the detail due to the thinness of the film and the sticky carrier. Okay. Let's talk a little bit about that's sort of the heat transfer film portion. What I want to do is first show you a video on the kiss cut process with Applique. So for those of you that do embroidery, or even if you don't, one of the cool things is that you can cut twill on your laser, assuming once again that it's a polyurethane base adhesive or polyester base adhesive and not a PVC. So you want to make sure you consult with your supplier. Of course, the Stahls material, Applique materials are compatible. And I'll play the video here, but the way the process works here, it's going to really give you some benefit. In this case, we have 2 layers of twill laying in the bed of the laser. And we've programmed the kiss cut ability to cut through the first layer of twill only for our inside layer, while cutting through both layers for the outside. It's something that when we sell you a twill service, we call it kiss cutting, but the idea is with a laser, now I can do that myself. So you'll see sort of an outline or contour come around this graphic, and then you'll really understand what's happening when we start to remove the layers. But not only can you cut through twill materials cleanly and accurately for applique work, but you can etch on the face of the twill material itself. And really, if you have embroidery, it just helps you justify that investment and opens up yet another application. And the beautiful thing is, typically if you're knife cutting twill, we know we have to sew the edge, but if you have a permanent adhesive twill that you cut with a laser, the edge is effectively sealed and you don't need to worry about sewing it. It can just be heat applied, which gives you some perhaps another price point without the machine time of the embroidery. So you can see it's kiss cut here. That's actually a white twill in the background. You see how everything, because we've used a pressure sensitive or sticky back twill on the top, everything holds in perfect registration, which makes for easy alignment on the machine. When I sew down my placement stitch, I can lay it all down as one piece and really prevent the individual layout that if I didn't use this process, if I cut the layer separately, I'd have to lay down the T separate from the A, from the Y, from the L, and so on. And so basically, not only does it reduce operator time in the heat transfer film process, but laser processing can reduce operator time specific to applique results. So I just wanted to make sure to point that out as part of today's presentation. Any additional laser recommendations? I knew there's been some new development as far as the laser itself and a new style of laser that tends to do the engraving process best for films. Do you want to speak to that at all, Dave?
Yeah, I tend to find that our mid-range sized systems create a better vacuum, and they tend to fit your material size better. My favorite system is the 18 by 24 because it works well with both your sizes of roll of material. It also is not too large where you get a decent productivity, but also a very, very good vacuum from the exhaust of the laser system. And that's why it tends to work the best for this material. Any wattage, any size will work depending on what you have, but if you're looking into a system to do this, that 18 by 24 tends to be ideal for this type of an application with a 50-watt laser and a honeycomb cutting table.
Good. So if you're keeping a list of recommendations, 18 by 24 honeycomb table and a 50-watt laser. That would be the ideal way to spec out the system. And you'll have the opportunity in the post-survey, if you're interested in a call from a universal specialist to talk more about a laser system, you can just answer yes, and we'll make sure we pass that along to Dave and his group so they can reach out and help you. Now, there are a couple sort of clarifying questions coming in here that I want to make sure we get to. Emma asked, wait, did you have 2 layers of material? Yeah, so what you saw in the twill process is we did effectively have 2 layers of material. You could even do 3 layers of material to kiss cut and process. So just starting with a background layer of twill in whatever color is the background of your graphic, and then taking a pressure sensitive twill, which basically just means it has a sticky adhesive side, and laying that on top of your background color. And then as Dave showed you earlier in the laser cutting process with programming the sort of speed and power of your red and blue vector cut lines, you can control sort of the depth of what you want to cut each layer to make life a lot easier. You can use perma-twill, poly-twill, or pressure-sensitive twill. The major difference is the pressure-sensitive twill is going to have the sticky backing. That's optimal for the foreground layer in kiss cutting. Perma-twill, if you don't want to sew it as a final application, you'll pay a little more, but it has a permanent adhesive on the back for just heat applying only versus having to sew it down. But if you want to save on sort of cost and get the best workflow, the standard poly-twill will work for your background. Another question comes in about how do we keep vinyl flat on the laser to cut, and hopefully I think we've addressed that through the honeycomb table. Anything else you want to add there as far as keeping it flat, Dave, that I missed?
You can, I mean, if you don't have a honeycomb or a vacuum table, you can tape the edges and hopefully keep it flat as possible, but you have possibility of reflection on the back, meaning the laser goes through the material, has nowhere to go. And so this becomes difficult. So I do recommend some type of either vacuum table if your manufacturer supplies it, or a honeycomb table which provides kind of both the cutting ability and the vacuum ability all at once. The other issues is shrinkage of the material when you're engraving a large area of it, and sometimes you want to tape the edges or pre-cut kind of your outlines out first when you're doing that, when you're running high volume, so that the whole sheet doesn't tend to shrink a little bit. I've run into this only in high volume or full field type applications. If I pre-cut a leaf area first, the laser can then it kind of relieves a little bit of the tension. The vacuum holds the individual parts down, and then we'll engrave or cut second. Mainly this is for the engraving, but the honeycomb table is necessary in order to do all these type of applications consistently and repeatable. Repeatability is key.
Yeah, excellent. Okay, good. So something that I would encourage you to do sort of as we work towards the end of our time together here to make sure we stay on time is if you have questions or if you try this application out, we have our Stahls TV forum just on stahlstv.com, and this video will be recorded and posted on there. As I mentioned, we'll make sure we upload the reference sheet under the Stahls TV blog post that we'll post up over the next day or two. But visit the Stahls TV forum and ask questions, post your results specific to your laser. So if you have something that's a follow-up that doesn't get answered in today's class, please use the forum. And as always, first, Dave, thanks for joining, bringing your knowledge and expertise to the Stahls TV viewer. I think we're going to see some really cool stuff, and hopefully business is growing as a result of this. So thank you.
My pleasure. I'm excited to see what people come out with.
Yeah, and we're, we always say our viewers are the most creative people in the industry, but it's a creative industry in general. But I know that we have some folks that attend all the classes and come up with some really cool stuff. So I think we'll get some good looks. And for those of you that attended, we want to thank you for sticking with us throughout the duration of today's presentation. And we want to encourage you to fill out the survey at the end when you log out, because that will help us guide future presentations and answer anything that we didn't get to. As always, thanks for watching Stahls TV. This will conclude today's presentation.